I would like to take your attention here more in the aspect of simulation in the local zones driven by dominating forces. Because as you saw previously, yesterday and today, we saw some presentations, Nathalie Durand and Monsieur Laurent Martin, about general simulation of currents in all lagoon. The strategy of modeling is the next. I use the code Marceau-D, which was developed by Yves Remer. This code has its own features. It's based on equations of Navier-Stokes and Boussinesq approximations. And also, it has finite different schemes. And the main feature, what I use here, and I will introduce you, it's a system of ranking. I mean, the possibility to calculate in the regions with using more precise cards, maps. So this the same scenario was taken for the Bear Lagoon. Two cards were taken into account. The first one, it's configuration 1, you see there, which has a size of resolution 50 meter. And the second card, which was measured by Samuel Meullier, which has resolution of 1 meter. So the general idea was previously to simulate dominating mechanisms for understanding which mechanism has more influence on the current structure in general. So we took in this presentation, I'll show you 3 scenarios. Separately, simulation of current induced by the wind, tide, and also EDF inflow. So here, the first scenario is a tidal effect. And I took the sinusoidal law for the tide. During my simulations, I saw that it doesn't play a very significant role on the energy of currents, but it's correlated with physics received by the reports of Ramad, that the tidal effect has 4 or 5 times attenuation inside the Bear Lagoon, and also a delay 4 or 5 hours. Also, the separate 3 types of wind were taken into account: Mistral, Tramontane, and southeastern wind. You see it here. And different volumes of EDF inflow. So I would like to take your attention for the local zone point of Bear, where I did a simulation. The same scenario, 2 types of scenario was taken into account. It's a different type of wind and the tidal effect. As you see, the structure of current is completely different for 3 types of wind. And also for the tide, here it's relative color to relative values. It's not big enough. And in all these 2 effects create this structure vortex. So in lower you see the data of Zoostera presence in 2007, for example. Also, I would like to show you one study, research. It's academical research which can be useful for the future projects of restoration of the Zoostera. It's a relation between current attenuation, current attenuation, and seagrass in all. There exist some functions, some dependencies of roughness, bottom roughness, and sizes of seagrass. It means number per square meter length and also diameter of leaves. And in this simulation, I planted in rectangular area seagrass with certain characteristics. And I estimated the values of currents and saw that inside the rectangular area, 4 meters inside, the current attenuates 2 times. Also, so it was another academical research for the future project of seagrass restoration. As Samuel Emile told, that the energy of waves play important role for the turbidity in coastal zone. So it's very important to introduce not just currents, but also coupling of currents and wave propagation in the same time. Here it was a try to simulate wave propagation using mass 2D. It was taken by X. Sorry, it's a high. I don't know why I didn't read well. So it's a monochromatic sinusoidal law for dispersive wave. And I would like to conclude all these studies to tell that we were capable to simulate currents and dominating forces for the local zones, which has a size relative to those terra patches, 1 meter. And according to this study, we have some perspective project, we hope, which is introduced here. It divided on 9 steps. So first 5 steps. It's introducing coupling of seagrass, coupling of models, wave and currents, and also comparison with experimental data which were measured by EDF and measured in situ in future. With using also aerophotos for estimating states of free surface, and of course to estimate a relation of seagrass presence, bottom roughness, for example, and patches, sizes of patches in hydraulic channel of herbiers by planting some plastic types of zoster. Thank you for your attention.